Okay, so in this video we're going to be looking at coordinate geometry of the circle, and specifically we're going to be looking at questions that involve tangents to the circle. So generally we're either going to have to find the length of the tangent from a point, or find the equation of a tangent at a point on a circle or not. It's important to note that if you have a circle, that a tangent, again reminding you, only hits the circle at one point, and the radius at that point of contact makes a 90-degree angle. It's a 90-degree angle with the tangent. So the radius makes a 90-degree angle at the point of contact. Let's jump into this question then. So find the equation of the tangent to the circle at the point 5 minus 5 on the circle. Important that it says on the circle. We'll look at scenarios where they give you a point where the point is not on the circle. So talking you through then what we are going to do. We know 5 minus 5 is on the circle, and we're able to find the center of the circle. Develop on what I just said then. Could you find the slope of this blue line? This center point. Could you find the center point? Yes, you could find the center point. Could you find the slope of that blue line? Absolutely, you could. What do you need to find the equation of a tangent, the equation of a line? You need a point and the slope. So you should be able to find the slope of the blue line. We know that it's 90 degrees to the tangent. So we're able to find the slope of the blue line, and then able to find the slope of the red line, the tangent, and then we can use the equation of a line formula. So we know that this is our common equation of a circle, and we know that 2gx is equal to minus 4x. So 2g is minus 4, and then g, or minus g, is going to be 2, and 2f is equal to 2. Quick rule of thumb to come from here down to the center: if you multiply by minus a half, or half and change the sign. What's a half of minus 4? Is minus 2, and then change the sign, you'd get 2. What's a half of 2? Is 1, and change the sign, you'd get minus 1. Or you could do it in the long way that we've done in the previous videos. You then also want to find the radius. Now, we're not going to use the radius in this question, but I'd always go and find the radius. It's a bit of free information. You might as well go and find the radius, and we find the radius is 5. So we know the center now, and we know the point that is on the circle. So find the slope of that blue line. Find the slope. So again, we're going x1, y1, x2, y2, filling into the slope formula. M is equal to y2 minus y1 over x2 minus x1, and we get the slope of the blue line is minus 4 over 3. Invert and change the sign to get the slope of the perpendicular, so that's where the 4 over 3 comes from. And then we're going to use y minus y1 is equal to m by x minus x1. And now in this case, the x1 and y1 needs to be a point that is on this line. What point do I know is on that line? It's the 5 minus 5. So I'll use the 5 minus 5 as my x1, y1. Okay, so for here, x1, y1 is 5 minus 5. We're subbing it into y minus y1 is equal to m by x minus x1. So it's y plus 5. Why is it plus 5? Because it's minus minus 5, which would be plus 5. 3 over 4, x minus 5, because this is the x1, y1. Multiply both sides by 4. This is what's getting to here. And then multiply out the brackets and rearrange. Look, it's nice to leave both answers in your ax plus by plus c is equal to 0, and leave it in y equals mx plus c form. It doesn't take that much extra work for you to go and do that, so I would leave it in both. Particularly, we're going to talk about this form now in a second. Any line that is parallel to this line must have the same slope. Any line that is parallel to it must have the same slope. That means all you have to change is the y coordinate or the constant to find another line that is parallel to that. The knock-on effect to that is any line that is parallel to this, because they're the same line, this and this is the same thing, you could go any line parallel to it would be 3x minus 4y plus k is equal to 0, or y is equal to 3 over 4 plus k is equal to 0. Plus k. They are parallel to the two yellow lines there. We're going to use this in a minute. So next question, find the equation of the two lines. Okay, so we want two lines, two answers, that are parallel to this line here. Okay, so I've just drawn in a quick sketch of this blue one. I don't even know if it's right. Look, it's just a sketch, it doesn't mean anything. But what do I know about any line that's going to be parallel to it? It's going to only have the constant that is different. The slope must be the same. Okay, so the two lines that I'm looking for must look like 3x plus 4y. And the only thing that's changed is the k, that constant at the end. And which are tangents to the circle. Okay, well, what else do we know about this circle? This circle is really interesting. It's x squared plus y squared plus 0x plus 0y minus 25 is equal to 0. And you might remember from the very first video, you should recognize this, that this has, well, this is 2gx plus 2fy, that minus g is going to be 0, and minus f is going to be 0 as well. So the center is 0, 0 for any circle that just looks like x squared plus y squared. And it's actually equal to r squared, you might remember from the first video. So we know that this 25 is actually r squared. So r squared is equal to 25, r is equal to 5, which leads us on to a diagram like this. We want the two red lines such that their perpendicular distance to the center is 5. And remember, perpendicular distance. Okay, perpendicular distance. Alarm bells should be ringing. We can use the perpendicular distance formula from coordinate geometry of the line and set it equal to the radius, because I know my A, my B, and my C. And my x1 and y1, the point that I'm interested in, is the center of the circle, which we've just found. And we set that equal to the radius 5. So we fill in everything that we know. Fill in everything that you know. Really nice that we're getting 0 and 0 being filled in. 3 by 0 is 0, 4 by 0 is 0, and you're just left with the modulus of k on the top line. Square root of 25 and the bottom line is 5, so we're getting 5 by 5 when you multiply across. And then how do you get rid of the modulus sign? You square both sides. We know we want two answers, so we're getting two values of k at the end. And what I haven't done, but should have done, is it asked for the equations. So I should be saying 3x plus 4y plus 25 is equal to 0, and 3x plus 4y minus 25 is equal to 0. I should be saying that, finish it off with the two equations at the end. Okay, this question is very similar to the previous question. It says find the equations, plural, of the tangents, plurals meaning two answers, to the circle x squared plus y squared is equal to 5. Remember, when it's just x squared plus y squared, that's really center 0, 0, and that's r squared. So the center is 0, 0, and r squared is equal to 5, so that means r is equal to the square root of 5. And the point 5, 0, and this is on the x-axis. On x-axis. From the point. If it says from the point, this is really, really, really important. From the point means the point is outside the circle. That's really important to know. So I want to find the equation of the red and the green line here. I don't know much about them. I know that they go through that point there, 5, 0. Okay, so there are two tangents we need to find. We know a point on both tangents, which is 5, 0. We just don't know the slopes of the tangents. Remember, what do we want to find the equation of a line? We need a point and we need the slopes. So we're going to pretend that the slope is m for both of the tangents. M is slope. I'm just going to say, grant, let it be m for the time being. The equation of the tangents is this then. So I am subbing in my 0 and my 5. So 5, 0 is x1, y1, but I'm pretending that the slope is m. And I'm multiplying it out. Okay, y minus 0 is 0, m by x is mx, m by minus 5 is minus 5m, and I change it. So this is ax plus by plus c is equal to 0. Remember, a is the coefficient of the x, b is the coefficient of the y, and c is the constant at the end. So c, orange is not a good colour on top of pink, maybe blue. C is minus 5m. There could be a scenario in which this would be minus 5 plus 3. Okay, so anything that doesn't have an x or a y at the end is our c at the end. Okay, brilliant. Well, what do I know? What do I know about the perpendicular distance between this line and this point? The perpendicular distance between that line and that point 0, 0 is the square root of 5. And remember, we have a formula for perpendicular distance. Okay, this mx minus y minus 5m is this line. That's what that represents. So the perpendicular distance from the center 0, 0, which is our x1, y1 now, to the line mx minus y minus 5m is the square root of 5. So we can put all of that information into our perpendicular distance formula. Zoom out so we can see it all in one go. Perfect. So our perpendicular distance formula, I know A was m, x1 is 0 and y1 is 0. My b is the coefficient of the y from the equation that I just made. So b is minus 1 and c was the constant at the end, which is minus 5m. A, again, coming from the equation of the line, is m squared and b is minus 1. And I start to multiply it out. M by 0 is nothing, minus 1 by 0 is nothing, so I've got minus 5m on top. M squared, fine, minus 1 squared is 1, nothing to be multiplied out on the right hand side. What do I dislike? What do I dislike? I don't like fractions. So I've multiplied across by the bottom line of the fraction to get down to here. I've multiplied both sides by the square root of m squared plus 1. Okay, brilliant. Now I'm at this point and I go, well, have I made progress? How many unknowns are there? There's only one unknown, and that's the letter m. So if there's one unknown on one equation, I'm very happy. How do I get rid of modulus? I square both sides. And remember that you're going to write it out as coming from here to here. It's really minus 5m by minus 5m. And squaring both sides, it's square root of 5, square root of m squared plus 1, square root of 5, square root of m squared plus 1. Square root of 5 by the square root of 5 gives you 5. Square root of m squared plus 1 by the square root of m squared plus 1 gives you m squared plus 1. Yeah, I don't want to leave that there. Now it's simply a matter of, it's back in. Now it's simply a matter of multiplying out the entire line. So minus 5m by minus 5m is 25m, 5 by m squared is 5m squared, 5 by 1 is 5. Continue to multiply it out, bring all the m squareds to one side, bring all the m squareds to one side, divide by 20, and then take the square root. Now, we should be getting two answers here. It should be plus or minus, because I want two slopes. Remember, I want two slopes. I want two equations. Then we need to go and sub this into the equation of the line. What did we know the equation of the line was? So brilliant, we knew it was mx minus y minus 5m. So the first one, we're going a half x minus y minus 5 by a half is equal to 0. Multiply everything by 2, x minus 2y minus 5 is equal to 0. And the other one was minus a half x minus y minus 5 by minus a half is equal to 0. Multiply everything by minus 2, you're getting x, multiplying everything by minus 2y minus 5 is equals to 0. There are your two. Sorry, made a mistake there. Multiplying everything by minus 2. It is multiplying everything by minus 2, but multiply this by minus 2, you get just 1, so you're getting x. Multiply this by minus 2, you're getting 2y, not minus 2y. Get rid of those circles. And multiply that by minus 2, you'd get 10, and then we're multiplying by minus a half, so you're getting minus 5 is equals to 0. And they're the two equations that of the tangents. So bringing it back to the start, they're the equations of both, even further back, they're the equations of both tangents in this case. And finally, the last type of question that you might come across, find the length of the tangent from the point. Okay, so I have a point that might be outside the circle, minus 5, 8, and I know it's tangential to the circle. Now, there are two tangents, but I'm only going to worry about one of them. So yes, there are the two tangents, but I'm only going to worry about the one that's on top. Okay, so if I could find the center of the circle, okay, center of the circle is easy to find. Remember I said you're halving each of these and changing the sign. So half them is minus 4, change the sign, would be 2. And half this would be minus 6, change the sign. Sorry, half it would be minus 3, change the sign would be 3. So the center is 2, 3. What about the radius? What do I know about the radius? I know the radius forms a 90-degree angle. And what do I want to find? Find the length of the tangent from the point to the circle. That's what I'm looking for. That length is what I'm looking for. What about this length here, the radius? Could you find the radius? Or is equal to the square root of g squared plus f squared minus c. Or is equal to, well, if this is minus g, this is minus g minus f. G is going to be minus 2 squared plus minus 3 squared. C is 3, so it's going to be minus 3. Or is equal to the square root of 4 plus 9 is 13 minus 3, square root of 10. So that's the square root of 10 here. What about this distance here? Could you find the distance between 2, 3 and 5, minus 5, 8. So x, y is 2, 3, x1, y1. x2, y2 is minus 5, 8. And use the distance formula, which is x2 minus x1 squared plus y2 minus y1 squared. So we're getting minus 5 minus 7 squared plus 8 minus 3 squared minus 12 squared plus 5 squared. 13 is going to be the answer here. 144 plus 25 square root of 169, which is 13. So I know this is 13 long, that pink bit. Well, what have I just formed? I formed a right angle triangle. Knowing that this is square root of 10, this is a right angle, this is 13, this is z. 13 squared plus, not plus, 13 squared is equal to square root of 10 squared plus z squared. 169 is equal to 100 plus z squared. Z is equal to 69. Z squared is equal to 69. Z is equal to the square root of 69, which can't be simplified. So we know the length of the tangent from point to circle is 69, square root of 69 units. Okay, so those 4 questions are really the ones that'll cover the whole section. I went through them a bit quickly, obviously, so I would recommend going through and taking each of them down before you go and tackle any question. Hopefully you found it useful anyways.